So let's take a look at each one individually, starting with the granulocytes. So again, some general things to kind of keep in mind. Starting with these ones here. Wait a minute. What should I start with? Neutrophils, basophils, eosinophils. Oh, I started back. My bad. I don't like that. Let's do neutrophils first. Neutrophils are first. Neutrophils, are they the most numerous? Yes or no?
Yes.
Yeah, about 70% of our cells look like this. Sometimes they're called PMNs. What does PMN stand for? Polymorphonuclear cell. What does that mean? Poly means many. Morpho means shape. Nuclear means nucleus. So how many nuclei do you see here? 1, 2, 3. So would you classify that as a PMN? Yeah. So sometimes neutrophils are called PMNs, right? Polymorphonuclear cells. Are they granular or agranular? Can you see all the granules on the surface? All the little dots, okay? Are they phagocytic? Do you guys know what the term phagocytic or phagocytosis means? Do you guys know what that means? If you guys don't know, it's okay, I'll tell you guys what that means. Phag or phago means to eat, right? Phagocyte means cell that eats. So this cell is going to actively look for and destroy and eat what? Bacteria, okay? So this is a very important cell for our immune system because it's going to really protect us actively, right? That's its main job. So it's a phagocytic cell. It's primarily going to be activated in acute infections, by the way. So let's say you get a sore throat and you're sick and you have strep throat. What white blood cell would be most elevated in this instance? The neutrophil, right? Hardcore elevation. You'd have neutrophilia, right? Philia is what? Love of what? The neutrophil, neutrophilia, okay? So really important when it comes to what type of microorganism? Viruses?
No.
Not so much. Parasites? Not so much. Really for bacteria. Make sense? Okay. Eosinophils are next. I'm going backwards. Do you guys see how they stain red? So eosin means what? Red or orange. Do you guys see how they're staining red and orange? And they're granular or agranular? Granular. Okay? So these guys right here are going to play a big role in allergies, like asthma, and parasitic. I should write this too. It's not on here, but it is on here. Parasitic infections. Let's highlight that right there. Parasitic infections. So allergies and parasitic infections. So if you have a patient that came back from, let's say, camping, or they went out, I don't know what people do outdoors. I'm not an outdoor person, but when people go out into the forest, what do they call it? Camping, right? They go camping and they play in the water, they drink the water, for example, and sometimes it's still standing water you should never drink because there's things like parasites in it. But let's say they didn't pay attention to that, they just drink the water, and they come back after a couple of days, they kind of feel weird, they're not feeling right. And we do a blood draw on them, a CBC, and we find out that they have eosinophilia, like a hardcore elevated count of this particular type of white blood cell, but they don't have any allergies. And you start asking, like, you've been out of the country or out and about? Well, I was camping out like 2 weeks ago, and okay, camping out. Did you drink the water? That's the first question you're gonna probably ask. Oh yeah, you know what? I was swimming in the lake and I just drank some water. Oh, okay, you probably have a parasitic infection. Then you do parasitic tests, right, to see if they got a parasite. Does that make sense to you guys? So eosinophils would be elevated in what kind of clinical scenario? Principally with parasitic infections. They also play a role with allergies as well, correct? So just keep that in mind, allergies, because what do they release? They're granular because they release things, right? What are they releasing? Histamines. Okay? And the last one here is the basophil. The basophil is pretty rare. I think it makes up less than like 0 to 1% of your total white blood cell count, so it's super rare to see. Sophia, you were talking about that earlier, about how rare it is to see a basophil, not too common. You can see though, is it granular? Yeah, you see all those granules on the surface, it just stains really dark, really purplish. What do they release? Histamine. So basically, you're going to see this with allergic reactions, principally basophils. You guys cool with that one? Good? Okay. No? Wait, repeat. One more? Okay. So yeah, the main thing that these basophils release is histamine. And what is histamine? Remember, histamine is a chemical that's going to make everything leaky. So it's going to cause vasodilation. It's going to cause your mucosa to run, eyes, nose, right? Respiratory secretions, everything becomes leaky, okay? Good? Okay, agranulocytes are next. So again, they don't have granules, correct? That's the big difference.
So in allergies, you would see an increase in eosinophils and basophils?
Yes, yes. You'd see both. But you'd see for parasitic infections, it would only be eosinophils.
Right.
Yes.
And then you would treat the allergies with antihistamine?
Yes.
Then you would-
Right, good stuff. Thank you, Joe. Lymphocytes. Are they granular or agranular? Agranular, okay. They're the second most numerous white blood cell, right? They're crucial to immunity. There's 3 subtypes, so, let's see here. Here's what a lymphocyte looks like. Again, there's no granules on the surface here, just the nucleus that you're seeing. No granules. And there's 3 types. You guys remember the 3 types? T, B,
T cells, B
and
cells,
NK.
and natural killer.
Very good. T cells are mainly in charge of destroying what? Viruses. Virus-infected cells. B cells, what do? B for antibodies. They make antibodies. And natural killer cells, they're gonna specifically destroy viruses. Because when we look at the immune system later on, we're gonna take a look at this in greater detail, and there's a difference between a virus and a virus-infected cell, okay? There's different things to that, but for now, I just want you to understand, in general, T, B, and NK. Those are types of lymphocytes. Make sense? Are they granular or agranular?
Agranular.
If I showed you this picture here like this, like we've been seeing, should you be able to identify them? Yes, okay? So the monocyte slash macrophage, it's the largest, it's the most phagocytic. You can see the change. Look at the blood monocyte and the tissue macrophage. Do you guys see how it changed? Yes or no? Do you guys see the change?
Yes. Yeah.
The blood monocyte is not phagocytic, okay? It does not consume, it does not eat, right? The tissue macrophage does, okay? So I want you guys to be aware of that. What does it look like in blood? Looks like a little U, right? Like a horseshoe shape or U, okay? So that's the blood monocyte. The tissue macrophage looks crazy, doesn't it? Look at that, looks pretty insane. It's this giant, multi-lobular, multi-nuclear PMN that is very, very phagocytic. Look at the monocyte versus the macrophage, right? So which one are you gonna call for help? Bruce Banner or Hulk? Hulk, right? So you want this guy to basically smash everything. Who's smashing everything here? The macrophage, yeah. Hulk smashing everything, destroying everything, protecting us. So that's the difference, okay, between the monocyte. So is the monocyte phagocytic?
No.
No. Is the tissue macrophage phagocytic? For sure, okay? Last 3 slides, guys. You can make it. You can do it. You can do it. 8:15. Get out of here at 8:20. 8:45? 9? No? Okay. 9:30? I can do it till 9. Are you challenging me? Challenge me. I'll make it till 10.
You can do till 9.
No, you gotta stay. Okay, so this is really important too, because you're gonna get some questions based on this too, about the steps of how white blood cells extravate. So these 3 things that you're seeing here is called extravasation. Extravasation means the movement of the white blood cell from the circulatory vessel into the extravascular space, right? This is called extravasation, okay? Extravasation. So what are the components to this? You've got what's called margination. So you guys see the white blood cell? As it's kind of sticking to the endothelial lining of the blood cell, the blood basement membrane that you're seeing here, okay? So it's kind of like rolling and kind of sticking to the basement membrane. Then you see what's called transmigration or diapedesis. When white blood cells need to get to where they need to go, chemical mediators are gonna be released. And the endothelial gap junctions, you guys remember gap junctions were like spaces between cells that are pretty tight? What happens to them? They open up a little bit. So what can squeeze through those interendothelial gap junctions? White blood cells. Do you guys see that? So they kind of move like a pseudopod, right? Like this kind of like amoeba. They kind of squeeze through those junctions between cells of the vessel